We are looking to start a position in NVIDIA, and I want to discuss the pros and cons and how we think about this. Just a reminder for listeners, the purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. So this is a great episode just to get a bit of a feel of how positioning works, which is a huge part of the business. This is the Not Even Wrong podcast. It's November 18th, 2021. This is Krim Delco. For the day, the fund is down 20 basis points. The market is up 30 basis points. For the year, we are up 44.4%. The market is up 22.9%. We're outperforming by 21.5%. So the idea here is that we want to invest in NVIDIA. Basically, we want to start a position in NVIDIA. And the reasons we want to do that is because let's step back a second. Let's go back to our principal stack. Let's go back to our mission and then work from there towards the investment. The mission of Orange Capital Partners is to generate wealth by investing in fundamentally new concepts and engineering practices with large impact. This is fundamentally new concepts and engineering practices is really another word for disruption. We just parsed it a little bit to be a bit more precise in what we mean when we talk about disruption. And the large impact is simply you can have disruptive new technologies in areas that are maybe not as impactful just because they're relatively small, and then you have maybe more impactful disruptions. And we believe that we just want to be in the more impactful disrupt on that side of the fence, because we believe that the returns are higher and also that the impact that we can have as a fund on the world and on society is going to be better. One of our principles, and this is now going to our principal stack, we have a principal stack consisting of 4 books. I don't want to talk about this too much here. Please go back. We have many episodes explaining our principal stacks. But one of the core principles within the principal stack is David Deutsch's The Beginning of Infinity, which in a nutshell says that we should have an open mind, that we can solve any kind of problem as long as the laws of physics allow us to solve that problem, we can solve it, and that we should just work towards the solution of that problem. Now, having said all that, so where does NVIDIA come in? NVIDIA has been one of the best performing stocks in the stock market period for years now. And the reason we want to invest now, and we haven't invested before, there's a couple of reasons. I want to first say why we want to invest now, and then why we actually did invest way back, then we sold, and we haven't been invested for a while. What is driving this investment? It's the idea that we will have a lot more virtual spaces going forward. And I want to throw in the word metaverse also. The word metaverse has been going around a lot. This is not about the metaverse. This is about virtual spaces. In a nutshell, this is about creating virtual reality animations that then help create physical products. This is where we believe NVIDIA has a much bigger role to play than the market is anticipating now. Not that we think the market is wrong on NVIDIA by any means. We just believe at Orange Capital Partners, we have a strong thesis, meaning a thesis that we believe in strongly, that the world of AI and machine learning is going into, let's call it a second phase, a machine learning 2.0 or an AI 2.0 or whatever, where we are going to have a lot more training in virtual animated spaces that then translate into learnings that can be used for physical products. Let me elaborate. Let's first talk about machine learning 1.0 and then 2.0. And before I go there, I want to say that I have all the respect for all the people and researchers that have been working on AI for decades, before 2012. So when I say the machine learning of 1.0 is the post-2012 world, I don't want to disrespect all the other people, the symbolic logic people and the neural net, the early neural net people and all that stuff. I know there's been a lot, even I myself in the 90s have studied at the University of Zurich, some of that stuff. So I know it was there, it just wasn't very effective. So I would say those were all early versions of what then culminated in the machine learning 1.0 world, and that was the world when ImageNet was published in 2012, and the Jeffrey Hinton paper and the machine learning approach to its vision was so successful, and that created sort of the revolution that we've been riding on for the last almost 10 years. This was machine learning 1.0. What is machine learning 1.0 is that we use algorithms to then test nature, see what's up in nature, and then define what's going on. So in other words, vision, perception, things like that. Some of the leading figures in machine learning, in my point of view, are in the field of perception and vision, because that is what this whole machine learning 1.0 world was. It was really getting a good sense for what's going on around us, sensing in any kind of way, in particular vision, have been revolutionary. The machine learning 2.0 world that we envision is the world where we have a lot better animations. And I'm going to elaborate what that means exactly, a lot better. But let's just leave it at that for now. So much better that we can use animation for self-play and self-learning and self-supervised reinforcement learning. This is the fundamental thesis that I want to put out there. That self-supervised reinforcement learning, a la AlphaGo 0, this is the idea, can be used in many other scenarios, in particular in the self-driving world. And we've spoken about this also after the Tesla AI Day. We believe that even Tesla, as a leader in full self-driving and self-driving technology right now, has an imperative to work on more animated learning, because we believe that the self-learning, the AlphaGo 0 approach, is fundamentally and eventually going to be a lot more effective in solving the driving problem. Now, what do we mean with animation? You see, animation has been around for a long time. We had games, we had game engines, we had all that stuff. The problem is there was always explicit knowledge put into it. So it was programmed by people. And that's fine, and it works for the gaming industry, and to some extent it works for people like Waymo and Cruise and all these people who don't have the data that Tesla has. They are relying a lot on animation. It's just not good enough. And even the words of Elon Musk, he said in the first AI day of Tesla that animation will never be able to replicate the physical world because it is animation, right? And then we have all the edge cases that Tesla's working on. The advantage of Tesla's data, and all these things are great, and we think that it will lead to amazing ADAS systems a la Google. If you think about it, let's say Google is kind of like ADAS. So Google is a very intelligent support system for knowledge. It doesn't create knowledge. It's not intelligent enough by any means to do anything else that just help us assist in when we generate knowledge, explanatory knowledge, and all that stuff. So that's kind of how we believe machine learning 1.0 with computer vision at its core can be useful for the self-driving community. But machine learning 2.0 can go much further by teaching the system how to drive through self-play if we have the right animation technology. And this is where we believe NVIDIA will come in. NVIDIA is talking about this to some extent. I think we are reinterpreting a little bit what they're saying, and we also believe that maybe they don't even know themselves exactly where they're going, because they're not as deeply embedded in the full self-driving space as we are. So what NVIDIA is talking about is things like BERT and DALI and these types of transformer models for languages and for video. In fact, the first time I heard about, I think it was GPT-3, right? It was Brian Catanzaro, head researcher at NVIDIA. He spoke about this. He said this is the biggest event in the whole sort of AI machine learning community that he has seen for a while. Brian is not a personal acquaintance. I've met him a few times professionally, and he's one of those types. You could meet him, I don't know if he surfs, but he just looks like the kind of guy that I could see at Ocean Beach surfing or skiing in Tahoe or something like that. And look, he's one of the guys, maybe one of the most important people at NVIDIA and therefore in the world of AI. So anyway, kudos to Brian. But I just want to say that he's very, I do cherish his opinion a lot. He at the first time I met him was, excuse me, he worked with Andrew Ng at Baidu in those days. And he was very instrumental in sort of guiding me into where this whole idea, let's say using GPUs and CUDA and all those things is going to end up in a much bigger adoption of machine learning techniques and computer vision techniques. So anyway, he was talking about this years ago, and of course he wasn't the only one who saw the potential of GPT-3, for example. But the potential for the GPT-3 and DALI in particular, and things like DALI, of course DALI is just the first sort of application of this. Let me elaborate. So GPT-3 is a transformer model for language. It comes out of the OpenAI research lab, and what they're doing is they're using, I don't know, 100,000 or a million, I don't know, books The machine just reads, and learns something, and then has a pre-trained model on which then we can use one-shot or few-shot or even zero-shot learning. So we can say something like, what is cheese in French? And the model will say fromage. And it hasn't been trained. We haven't been going through the French language and teaching the model specifically what cheese means in French. The point here is that we have a pre-trained model on which we can then build knowledge, and it has a lot of knowledge within the context and the interconnections between the language and the words and all that kind of stuff. I don't want to be too specific about this, first because I'm not that proficient, but also this podcast is not about transformers. I have to be very cognizant about this. So for all the tech geeks out there who want to know more, please go. There's many YouTube videos about what GPT-3 does and why it's so successful. But from a practical approach, it just helps people, let's say, write text. You can start with, Jesus was the founder of the Christian community, and then you can go from there and write a story which would be pretty coherent. Maybe he wasn't the founder of the Christian community, I'm sorry, but anyway, I hope you got my point. Now, DALL-E is the same for pictures, and this is where NVIDIA comes in. This is where we believe machine learning 2.0 comes in. We have a video. We can shoot a video, let's say a road in Alaska, and then DALL-E or something along those lines, a transformer model for video, for pictures, can then build an animated version of that road, an icy road with rain, deer on it, bears on it, all that kind of stuff. The key is, if we do this in an animated world, we can do many versions of that road in a very realistic scenario, because it was trained on real world pictures. So it's trained on the real world, and the transformer model has knowledge gathered from the real world and uses that knowledge then to create animations which are rooted in the real world, and using machine learning, so the power of computation, to create many versions of this road which are realistic. So in other words, we could have our, let's say, self-driving truck drive this road 1 billion times in 1 billion different versions and learn how to navigate through self-supervised reinforcement learning. We don't have to actually go and drive this truck. But it's going to do this in a real in an animated world, which is rooted in a real world, and the translation is through machine learning, through transformer models such as DALL-E. This is where we believe the future of machine learning and the future of AI lies. And NVIDIA plays a crucial role in this space because of its absolute leadership in any kind of image translation, video type of problem that connects computation, machine learning, and the representation of that model, meaning display and things like that. All of these things, NVIDIA is a leader. That's why we believe that it is time now for us to put on a position in NVIDIA. Even though the company has done so phenomenal, it went from a $50 billion company to almost a $1 trillion company. We have invested early on because we believe that GPUs will be the key for the machine learning 1.0 revolution. Now we believe that the same approach that NVIDIA is using to machine learning, which is GPUs in particular, but then also interconnect and things like that, that all of these things will be absolutely key in the machine learning 2.0 world. Again, it's about animation. It's about creating virtual worlds which are rooted in real physical worlds that create real virtual representations of the real world that we can use for self-supervised reinforcement learning. This is the fundamental thesis, not just for NVIDIA, but also for machine learning. We believe that companies like Tesla will have to jump on that bandwagon, because otherwise disruptors could come and disrupt them. And that's very serious also for us. We have a very large position in Tesla. So we have to make sure that we are not just invested in this, but also make sure that our largest positions don't get disrupted by this. This is how serious we believe this is. So far, we don't see any disruptors coming from that space. Nobody is doing an AlphaGo Zero approach for self-driving yet. Again, Waymo could be a threat. We have our issues with Waymo. We spoke about this yesterday, about humility and the lack of culture that we believe will hold Waymo back. But there could be others, probably some startup types that could succeed. So to summarize, we are going to put a position in NVIDIA, and for that also we have to probably sell something. We have one of the constraints in putting on positions is leverage. So we are already at a point where we have quite a bit of leverage. We have some room for leverage left, but it's very little, and we might have to sell something, and this is going to be a problem. I'm going to discuss this in a future episode. For now, let's just stick with the thesis. Excuse me. NVIDIA is an investment into the future of what we call machine learning 2.0, which is machine learning based on animated worlds that are rooted in real worlds through transformer models. And if we have animated worlds that can be used to a much larger extent when developing AI, then we can do self-supervised reinforcement learning, which is a lot more powerful in solving very complicated problems, such as, for example, self-driving. Thank you.